If you find yourself really struggling in college algebra, then it might be because you don't understand a core concept, and that is the order of operations. Now, to help us better understand the order of operations, there is an acronym that we use called PEMDAS. PEMDAS. So we say PEMDAS, and this is sort of a code word for parentheses, exponents, multiplication, division, addition, and subtraction. Now, quite often, you'll need to use this when you're simplifying. And to just show you how it works, I'll just go through with this example. So we have here 5 squared minus 2 plus 2, but those 2 plus 2's are in parentheses. Then we multiply 3, and then we finally divide 12. So going with the order of operations, the first thing we would start with is whatever's in the parentheses. We wouldn't want to... Well, if you really wanted, you could do the exponent first, but we certainly wouldn't want to multiply 3 and 2 together, or 2 and 3 together, because that would actually mess this whole thing up. So let's start with what's in the parentheses. So that would be 2 plus 2. So we'll write 5 squared down here. And then 2 plus 2 equals 4. And then once we deduce that, we can just get rid of the parentheses. We just leave 4 here. Then we can multiply by 3. And then finally, we would divide by 12. Now, if we were to subtract 4 from 5 here, I'll show you how you could make a mistake if you weren't being careful. So if you were to subtract 4 from 5 here, you would wind up getting maybe 1 squared times 3 divided by 12. And this would not be correct. So what you want to do instead is you want to take a look at 5 squared. So let's do that. So we would ask ourselves, what does 5 times 5 equal? Because any number raised to the second power is just that number multiplied by itself. So we would just write 25, because 5 times 5 equals 25. Then we subtract 4, multiply 3, and then divide by 12. But we wouldn't really do it in the order that I just said, because we just finished parentheses and exponents. But before we would do the subtraction here, where 25 and 4 are, we need to look at multiplication. So that would be right here. The next part we're going to focus on is right here, which is going to be 4 times 3, or maybe more specifically, negative 4 times 3. So going forward with that, we'll write 25 down here. We'll put the minus sign because we know a negative number and a positive number multiplied together will equal a negative number. So that's going to be a minus 12. And finally, we're going to put the other 12 here for division. And speaking of which, we're going to focus on that next. So now we'll be looking at the division over the subtraction, because that is higher up on the order of operations. So 12 divided by 12, or negative 12 divided by 12, is going to equal negative 1. So 25, we'll put that there because this is the next step. negative 12 divided by 12 equals negative 1. And finally, we are poised to finish solving the problem. 25 minus 1 equals 24. Now, we've done all of the steps in the order of operations, finally. And you might be confused. You might be saying to yourself, well, wait a second. I've done math problems in school where I've subtracted first. So why would we start with parentheses first or exponents first here or multiplication before that even? Well, the problems you're thinking of, so here we were simplifying, right? And there was no equal sign here. You might be thinking of these sorts of problems where you are solving for x. And I'm just going to write down the PEMDAS again. PEMDAS, which of course stands for parentheses, exponents, multiplication, division, addition, and subtraction. So there's no parentheses here, there's no exponent, but maybe thinking about this, you do multiplication first, and you would think, well, or division for that matter, and think that you would divide 4 on both sides of the equation first. That isn't really the way you'd want to go about it, because when you're solving for x, and you're working across the equal sign, you actually want to do the order of operations in reverse. So to show you what not to do, say if you were to divide 4 on both sides here, this would be a mistake. If I divided 4 here and I divided 4 here and got, x plus 5 over 25 over 4. This is something that you certainly would not want to do. Sometimes in math problems, you actually kind of do want to divide on both sides, even when that's not the step. But if you were to do that correctly, it would have to look like something like this, right? You'd have to divide it like that. But this would convolute the problem anyway. Maybe I'm probably just talking about too much right now. How you'd actually want to solve for x here is you would want to subtract 5 on both sides of the equation first, because remember, we're working in reverse, so we're going up. So we're going to start with subtraction here. So we can subtract 5 on both sides of the equation. You wouldn't have to subtract it from 4x, really. You would just sort of subtract it here. So you do that. And then the positive 5 and the minus 5 here are going to cancel out. And that's going to leave you with 4x equals 20. Because 25 minus 5 equals 20. And finally, you would divide both sides of the equation by 4 because there's no addition, so you skip that. Then you go to division, which would be, in this case, the next step. And finally, the 4's on both sides, on the top and the bottom here, would cancel out. You would be left with x on this side of the equation, and then 20 divided by 4 is going to leave you with 5. So you get your final answer of x equals 5. So remember, if you're solving for x, to try to summarize that, when you're simplifying, you want to just follow the order of operations in their normal order. And usually simplifying means there's no equal sign. Or you're just working on one side of the equal sign. And then if you're solving for x, where you're going across the equal sign, if you're working on the other side of the equal sign, then you want to work up. Sometimes you might want to do a mix of both, and I'll show you an example of that right now. So this is an example of solving for x. We have here 6x plus 4 to the second power equals 34. And I'm just going to write the acronym one more time. So PEMDAS. And you could actually subtract a 4 squared on both sides, but it might be better to simplify 4 squared first. And because we're simplifying 4 squared, we are working on the same side of the equal sign, so it's actually permissible for us to go in the normal of operations. So we would actually start with parentheses there. We would start with what's in the parentheses. Well, actually, in this case, there are no parentheses, so let me erase that. We would start with the exponent first. So in that case, it would be this. It would be the 4 squared. So we'll go on. 6x. 4 squared would equal 4 times 4. That's going to just equal 16. So 6x plus 16 equals 34. And now, since there's no simplifying we could really do on either side of the equation, because remember, simplifying, when you go in the normal order of operations, you're simplifying. So you're just working on one side of the equation. But since there's no real way to simplify 6x plus 16, and we're trying to solve for x, now we're going to work backwards. So now we're going to start with subtraction. So we subtract 16 from both sides of the equation, and those are going to cancel out. This positive 16 and the minus 16 are going to cancel out. We're going to be left with a 6x, and that's going to equal 34 minus 16. That's going to be 8 on this side, and then we had to take 1 from the 3, leaving a 2. 2 minus 1 equals 1. So we have 6x equals 18. Finally, there's no addition, so we just skip that, and we just go to division, because we are still working in the reverse order because we're working across the equal sign here. So now we're going to pay attention to division. And we can divide 6x on both sides of the equation here. And that is finally going to leave us with x equals 3. So keeping this in mind when you're working with just about almost every problem, I want to say, is going to use some variation of the order of operations. So just keep these operations in mind when you are working in college algebra. I hope this video was helpful to you. If you are looking for some additional instruction, I offer online tutoring to struggling college students so that they can fix their foundations in mathematics. If that's something you're interested in, check out the description of this video. You may find something useful for you. Thank you very much for watching.